Welcome everyone. Welcome to another episode of Coding Talks podcast. This is Vishnu and I am the host of this podcast. The podcast will be available on all podcast platforms as well as on YouTube. Please check out my previous episodes related to AWS and GenAI. I am a .NET developer, AWS community builder. I work with different cloud technologies like AWS, Azure, and so on. In today's episode, we will be discussing more about one of the Agentic AI frameworks developed by AWS and is in the open source platform, which is the Strands framework. Strands is a framework which can be used for developing Agentic AI applications. Very quickly, one of the benefits of this framework is its simplicity in developing application. Even if you have very less familiarity with Python, still you can develop an Agentic AI applications quickly. The reason for that is the framework, the Strands framework abstracts most of its complexities. In addition to that, it offers a rich integration with the different model providers, including Bedrock, Anthropic, and other providers. That essentially means with minimal code, you can easily spin up an Agentic AI application and you can enhance it with advanced scenarios. You can implement guardrails on that, or the security best practices are already implemented. Tracing and monitoring, that is also there within the framework. You don't have to write extra code for that. And moreover, this can be deployed once you developed such an Agentic AI application. This can be deployed onto various platforms depending upon your business needs. We will discuss all those in today's episode. All the opinions that I expressed through this podcast are purely personal and do not represent any of my employer's view in any way. With that, let's start. Before looking into detail about the Agentic AI development using the Strands framework, let's understand the difference between the generative AI applications and the Agentic AI applications. We are not looking into the generative AI. Everyone of you know that in generative AI applications, an underlying model works behind the scene to generate contents. Content could be multimodal contents. It could be text, video, or maybe a combination of both, or any type of model. So most of the models can generate multi-model combinations. It can also accept the multi-model combinations as well. And in addition to that, we will be providing a prompt in a natural language. Based on what we provided as a prompt, the underlying LLM understands our intention and then it will generate the output in the form of multimodal modalities. This is what's happening in a generative AI system. And the central part of, or the core part of that system, which is that model, usually that model hosting and its maintenance and all, usually we could leverage it from some cloud services like the one from Amazon Bedrock. It offers a managed API where we can connect to that service and we can utilize all those underlying models on the fly. You can connect your existing applications to the Amazon Bedrock service, select a model of your choice, and can make inference out of this. So this will make your application a generative AI intelligent application. You can do a lot of generative AI related applications like a text summarization, or to generate a new content, or to provide recommendations. All those can be done with the help of a generative AI use cases. And a recent advancement in generative AI is called the Agentic AI, where one more additional layer is added on top of the generative AI, which is the feedback loop mechanism. How this works is like similar to generative AI, it generates the contents, but it will go through a loopback mechanism by which it will analyze the output, and then evaluate that with the original prompt, and then it repeats that step again through the LLM, enhance it more until the desired output is received. Because this agentic AI systems have the concept of feedback and enhancing again like a loop, that means it can do actions on behalf of user. When we provide a natural language prompt, it can iteratively go through that prompt again and again and evaluate the results until the final expected response is generated. This means it can take actions. Because of this additional loop mechanism and the ability to take actions, nowadays agentic AI systems are getting popular, and you can see a lot of such use cases and implementations already in many of our existing applications. Like recently, Spotify announced the AI Create playlist, by which we can just provide a natural language and it can provide a playlist for our choice. That's one use cases. And similarly, in development, previously we saw the integration of chat-based AI systems, where we can connect with that chat through the chat with these AI systems and understand about the code, or can write the code and so on. Now, the agent mode is also available in most of the editors, including Visual Studio Code as well as on Visual Studio Professional. Many other editors also this will be available. Agent provides more interactions, like you can provide a prompt and it can develop a feature, write documentation, it can generate unit test. Sometimes it can help you to identify the issue, debug the issue and fix the bug as well. All these are the characteristics of agentic system, and this feature of this characteristics of AI agentic system is now getting popular in other areas as well, especially to automate the business workflow use cases. Complex business workflows can be automated with the help of the AI systems, agentic AI systems. You could have multiple AI systems work in combination in a centralized orchestrated way, or in a kind of an individual decentralized way, so that you could achieve some of the business outcomes with the help of these agents. All of this is happening transparent, so that the end user may not aware that these agents are working behind the scene. It offers a great experience. So the user will be connecting to a central agent, which will delegate all these tasks to different other agents. And finally, the output is consolidated from all the different agents and presented to the user. User experience will be good, and also they could get more than what they are originally expected, because these agents can work in parallel and it can achieve the task as well. Because of this capability, agentic AI development is getting popular. And now comes to the central theme of this podcast, that is the Agentic AI development using Strands. You may be wondering, there are a lot of other frameworks out there. Yes, there are a lot of other frameworks, and you can develop Agentic AI systems. But this Strands framework can be think of like as a complete package where you could start creating a simple agent. You can enhance it further to a simple agentic AI model or a kind of a multi-agentic AI system. You can create conversational agent, CLI-based agents, and much more. And all for all these, the Strands offers a good support. Good support in the form of framework level support is there. Strands has all these features for developing applications. Boilerplate templates are there. You can create different tools, different integrations with the different external services, different deployment patterns, and so on. Similarly, the Strands offers a good documentation as well. If you search about Strands in any search engine, you would get the Strands official documentation where it explains clearly about how to get started with that and how to spin up a simple agent, and how you can expand it to complex scenarios to support your business activities. So now what I am going to explain in this episode, all the opinions are purely personal and do not represent any of my employer's view in any way. The opinions that I am going to explain here will give you an overview about how you can start a development using the Strands framework. The requisite for this is to have a laptop where you have to install the Python SDK. Strands is developed using Python, so you need Python for that. And the code you are going to write in Strands framework, that is also Python. Keep in mind that you don't need to be an expert in Python. Even if you have some basic understanding of programming, whether it be any language, JavaScript, C# or whatever, that would work. The main reason is that most of the underlying implementations are abstracted by the framework itself. So you could write minimal code. And another benefit is that Strands have an official documentation where all these things, how to get started, how to develop a multi-modal agent, how to implement the best practices and all, everything is documented. It also has a supporting GitHub repository where you can refer the code base and you can simply generate it. And with the help of AI systems, nowadays you can just provide a prompt and you could connect your existing AI systems, whether it is Amazon Q or Copilot. You could connect your existing AI systems to use the Strands MCP server so that your AI systems understand how the Strands will work behind the scene and then will generate code. Even if you don't connect the MCP server, still it will work, but if you connect it, the advantage you would get is you would get an official support directly from Strands framework in the form of an MCP server. So your AI systems, your local AI systems or development AI systems will get more context about how the Strands works from its official channel itself, and it can suggest you more relevant contents. So that is a kind of an AI form of development. Even if you, without connecting the MCP server, still it works because already a lot of public code, like GitHub-based codes are available, and AI can generate content based on that from the existing public documentation and the code base. So that's not an issue. Now, to start, install the Python SDK is a must. And once you install that, then you have to install the Strands package in using the pip. So pip is a kind of a package manager for Python. It's similar to the NuGet package manager in .NET and the NPM in Node and React. Similar way, you can install the Strands package to your system, and once that is there, you can create simply a Python file. Whatever name you can provide, you can create a simple Python file, and you have to just add 3 lines of code. The first line is to import the Strands framework. Second line is to create a new agent. By the syntax is like agent equal to new agent. Third line is the way by which you are directly interacting with the underlying model. So you will provide a command like agent, and in bracket you will provide the prompt. When you get quick start, you can mention anything to that model. Whatever the model knows, it will respond. You can tell about that, like tell a sentence about 100 words about generative AI or the agentic AI, and it will generate that. So this are from the code level you can create, and then you can run the file just like you run any other Python file. So the command for that is also available from the documentation. I'm not going into detail about the commands. Please accompany the documentation quick start section to get quickly start. You can easily follow without any further help from anyone. And initially when you run this, you will encounter some issues. Reason is like whatever we have written in 3 lines of code, what happens behind the scene is when you run this, the Strands agent will connect to the default model provider. Model providers are providers or cloud services which can provide you with these different models. So usually the core of any generative AI or agentic AI system is its model, and Strands also need a model. The default model of the Strands is AWS Bedrock's Cloud Sonnet model. Actually, Bedrock is a managed service, like through an API, managed API. Your applications can connect to the Bedrock and infer out of it. Because of that, feature is there in the Amazon Bedrock. Strands by default use that. And the default model is also switched to the latest version of the Cloud Sonnet model. That is, as of this recording in November, maybe at a later point of time, this might change. It might change to a different model. There is a possibility. We cannot predict that, but at this time, the default model is Cloud Sonnet from Anthropic, and that is available through Amazon Bedrock. But you don't have to do anything to connect to the Bedrock and all. It's already there. No additional lines of codes are required. But what we need to do, 2 things we need to do. One is like you need to ensure that your account, whatever AWS account you have, provide that key and the secrets in the AWS credentials. So this is part of any AWS service development, where in your local system, you need to configure your AWS credentials. The secret and the key can be get from the AWS console. And once you have that, you have to configure it using the CLI command. To run the CLI command on a fresh system, if you are not familiar with AWS, you have to install the AWS CLI. AWS CLI is a separate package. It's a exe which you have to install. You will get that from the AWS documentation websites itself. You have to install that, and once you install that, open the command prompt and run AWS space configure. This will prompt you to provide the key and the secret that the CLI will store temporarily in your system under the environment variables. So that's a kind of a secured practice by which only you will have access to those environment variables, no one else. and your code also can access that. So that way you can develop the applications, and when it gets deployed onto the production or other environment like container, EKS, the underlying environment variables will be read from there. So that's how it's working. The short summary is that we don't commit any configuration related things like credentials or something into configuration, not configuration, credential related or secret related information onto the source code. Even if you do that in some way, it's wrong. It's a wrong practice, and there are mechanisms within the AWS to identify and alert you regarding that. Okay, that's all a separate topic. Now, once you configure that credentials in the form of AWS configure, you can run it. So the thing is, in case if you don't configure those credentials initially, you would get an error. You can expect an error, something like you could expect an error, something like access permission issues or something that you could expect. And second thing, you want to make sure that in addition to this, whatever account you are using, whatever credentials you are using should have permissions to access the Bedrock. So you have to make sure, like, you have to make the permissions correct. And since we are connecting to the underlying AWS Bedrock service, and there are a lot of different models available within the Bedrock, Bedrock models should be enabled before its use. That means we have to enable the Cloud Sonnet latest version of the model from the Bedrock console. There is an option by which we can see the existing models, and we can enable it from within the Bedrock console. If everything is done, then you can run the agent.py file from the quick start, and that will display the result. So what happens underlying is whenever you run this, Strands framework actually passes the handover to the underlying model in Bedrock and do the inference and get the output from there. So this is how it's working. Hope you got a base understanding of how you develop an application, a simple application, Agentic AI application using Strands framework. Here we didn't write any code related to connecting to AWS Bedrock, and we could simply spin it up with a minimal level of code. Now, what kind of applications you can develop with this? You can develop conversational agents. You can develop CLI-based agents. The benefit of CLI-based agents is that instead of having to provide the exact command, you can mention in like a natural language format. I want to create a new file in this specific location. Behind the scene, the natural language ability of the model help you to decode what your intention is, and then it will create the associated tools. So this kind of Agentic AI applications can be developed easily with the help of Strands framework. How you do that is, right now we discussed about a simple agent, like initiating an agent and providing a prompt. Now coming to different Agentic AI development, you actually define the different tools in the form of different tools, different methods you mention, and you decorate that with the different tools and a system prompt as well there, so that the underlying model can understand, okay, if the user intend this kind of natural language sentences, then it can infer from the tool definition itself, like we should call this a specific method. And also a lot of additional tools are also available within the Strands framework, like tools for creating files, tools for creating folders, tools for file manipulation, tools for accessing other services, and so on. All these different integrations with the different AWS services, that all are there within the Strands framework itself. So it's a matter of just defining a method, decorate it with a lot of system prompts, like what you want to do with that, how that specific method should be behaved, and then you can initiate the tools. And if you look into the example sections of the Strands documentation, you can find a lot of example, and I will quickly cover 2-3 examples that I remember. One is the multi-agent example, where 3 agents are defined inside the framework. Means 3 methods. One method is the researcher agent, which role is to go through a specific endpoint like API and get information from there. Second one is an analyst agent, which does the analysis from that. So the goal here is to create a kind of a researcher agent or a kind of a multimodal agent which identifies some information, then it analyzes it to get the insights, and finally it summarizes and writes to a different file. In normal development, you would actually write separate methods or private methods to fetch the data from there. But here we follow a kind of an agentic AI development using Strands, where you define 3 methods, primarily defining 3 agents. One is the researcher agent, another one is the analyzer agent, and third one is the writer agent. And the analyzer, the researcher agent, its goal is to identify the different informations from the API, parse it and hand over to the next model, which is the analyzer agent. And analyzer agent will get input from the previous agent, which is the research agent, and then it will go use some other form of a model, like a kind of a different model specific for its summarization, and then it will present that output to the writer model, where the writer agent is responsible for writing onto a specific folder or a file. And the beauty of this Strands framework is that for all these different agents, supported tools are available. For the researcher agent, there is a tool for fetching the data from the API. Similarly, for other, these are just minor examples that I am mentioning. There are a lot of different tools are available, and if it wants to connect from some specific AWS services or something, that option is there. It has external third-party connectors. So community support is there for the Strands framework, so that you can connect to different integrations. Similar way, in the analyze agent section, you would need some other model. You might need LangChain. You might need some other model like Llama model or Anthropic's different model or GPT or Gemini model. In that case, you can use that. You have the provision to use directly from multiple providers. You don't need to stick just to AWS Bedrock. You can connect to other models as well. Lot of model supports are there. Feel free to go through the Strands documentation to understand what all model providers are currently supported. So you don't have to bother much about, I specifically tied to AWS Bedrock. Bedrock is a good service. It's a simple to understand, easier, and a rich integration within the AWS ecosystem. But if you are accustomed to use any other model, feel free to do that. You can have your custom models as well. So that are some of the advantages provided by the Strands. And the final part of the this agent workflow, you would need to write that onto a specific folder. Sometimes instead of writing to a file, you might need to write it to somewhere else. So different tools are available. And if you look into the code examples, you can see you don't need to write a lot of different lines of codes to achieve this. Everything is abstracted. So you just have to provide the tools and the intended intention of that through the system prompt, and rest will be handled by the framework itself. So these are some of the general outline, and this way different agents you can combine in different formats to achieve your business workflows, achieve the goal of your business workflows. Sometimes it might be individual agents working parallelly. Sometimes it might be one agent or the orchestrator agent, which aggregates all the information from other agents and then orchestrate or coordinates the other agent and achieve the desired task. So a different configuration option is also there, and you know how this is working. It actually connects to the underlying models, and similarly, just like as we mentioned, the agentic AI systems have an extra layer called a loop mechanism. That similar loop mechanism is also exist here in this bed and in this Strands as well. That is transparent to us. We may not aware of that when we define a tool or a method. Actually, it's running kind of a loop, and this framework will handle all of these things. It handles the inputs from the user, parsing, validating the different underlying tools, and the outputs from the tools, handing over to the next model and next agent and so on. All will be handled by the framework itself. So that way you can, an agent loop is a major component in the agentic AI system. So this loop iteratively handles the execution until the return got achieved. So that's why even if we are connecting to an agent, to an API using the researcher agent, we will specify in the researcher agent prompt like you have to go to this and this API to get the relevant content, and whatever type of content you have to get it, you have to get it that way, and we can provide that as kind of a system prompt. So these are the prompts which we are defined inside the methods, and based on that the LLMs will understand the intention, and then it will repeatedly execute the underlying tools like the API tools until the goal is achieved. So that means you don't have to write if clauses or conditional clauses to evaluate the response and so on. Everything will be handled by the model itself. And the model in this case, in the simple case, is the Amazon Bedrock. But you have the freedom to choose any models as you like, not just the Bedrock models, any other providers as well. Actually, Bedrock is one of the managed service provided by AWS, which provides the output. Similarly, other kind of providers like Anthropic, Gemini, and others are also there. You could use anything with the Strands agent actually. Okay, now we discussed about the concept of the model. Next, we look into the concept of the state. State means see, when different agents are working together like this in Strands, there should be a coordination that should be happen. Just like in the case of React, if you compare or if I say an analogy of a React component, you know the concept of the component. So similar way, internal state of the different agents that are not specific to the conversations can be kept inside the agent itself, and such facilities are available within the Strands framework. You can store key value pairs, you can validate it, you can enforce certain schema and all. So this can be used for your agentic AI application development. And also another important thing is about the session management. Session management is a core concept. Strands handles that by default. This Strands agents are capable of deploying to multiple targets like a container or systems that are of a kind of an ephemeral nature. That means at any time it can, those services can be terminated and it can be restarted. So that means somehow we have to keep the session of the different users that are connected to these agentic AI systems. By default, that option is also there. You could have a text-based session store where you can store where you can store the session in a specific folder, or if you want to store that inside a S3, that option is also there. So that means you don't have to worry about whether how to restart the conversation when the user arrives at a later point of time, or some temporary error happens which made the services restart. That all will be handled by default. Then another thing is about the conversations, like conversations between the consumer from the users, messages. Then there are other forms of messages also happening in between the different agents and the underlying models, agents to agents, and so on. Lot of these informations will be handled by the framework itself. And you could go through the documentation and read about it. What are different type of the conversations are aware. Conversations can be extracted through programmatically. All those informations are documented. And to summarize it, the idea is like it will manage everything. The conversation and all will be managed everything, so that it offers the maximum quality output with less context overload. So there's a balance that these conversations between different agents and the different systems should be there, and that will be automatically handled by the framework itself. Okay, and now we can there are a lot of other features also. We cannot cover everything in this episode, but these are the summary, and if you are interested in learning more about the concept, go through the Strands agent documentation. You will get a better idea about those. Just a moment. Okay, so now we will look on some of the security best practices. It's not like a best practices, some of the security concepts which are there in the Strands framework. Like every framework or services that leverages this generative AI, the principles of responsible AI should apply there. And Strands framework has inbuilt responsible AI principles, like one such principle is the least privileges. Like these different tools have least privileges to access, and also the concept of guardrails can also integrate, provided if you enable the bedrock guardrails. Some limitations are there, and it's specifically has a relation with the underlying provider that you are using. So if you are using Bedrock, it has guardrails by default, and it offers, and similarly for other providers. If you are using some other, it depends on that provider. And similarly, if you want to redact some P2 information, so P2 informations are sensible personal informations, and if you want to redact those information, you could achieve that either with the help of third-party libraries, and if you're interested in have a look at that, please check out the documentation. I think I have covered the development things, and there are some of the patterns also, like what kind of patterns you can leverage about this. And when the Strands framework was released, there written a blog, and AWS shared a blog, and I will attach those blog information as well in my show notes. You can go through that as different forms of patterns you could leverage. And There is a lot of other things also you can take benefit out of from this framework. One example is that the concept of a typed response. Usually, the output from a model will be very verbose with a lot of informations. And if you want to make it a kind of a JSON format suitable for your next model, you could achieve that with the help of the exactly not a Pydantic one library is there which can help you to typify an output from the model, and then it can hand over to the next model. And another one important concept or feature of the Strands framework is the MCP server support. It is there by default, so that means that your agents can connect to the external MCP servers. MCP servers are kind of a protocols which offers a gateway to other systems. It can get content, it can take actions and so on. Lot of MCP servers are there. Even from Amazon, there are certain MCP servers. During the beginning of this episode, we discussed about a MCP server from Strands framework itself, which helped to improve the context awareness about Strands, especially for the local AI development tools. Similarly, for your agents also, it can leverage other MCP tools that are available, and it can connect to there. Then streaming support is there by default. Streaming support is there so that you can stream the output to the user to provide a better experience, agentic AI experiences. That support is there. Okay, and these Strands support different kinds of models as well, just like the models support textual images and sometimes multimodal as well. Strands can also support different types of models. It depends upon the underlying foundation model or LLM which you actually use. You can have different forms of multimodal combinations. That is also possible. Then next we are going to discuss about how we could deploy this agent which we developed. In the example which we discussed, we thought of a simple agent. You could theoretically deploy that into any of the different deployment targets, whether it be serverless based Lambda or a serverless based container like a Fargate. You could do that. Or if you want to achieve a kind of a container based deployment, you could deploy that onto EKS as well. You could also deploy that to EC2 for special cases where you need full control, but that won't be a cost-effective strategy. Now let's look at the different ways by which you can deploy this. Let's start with the Lambda. Lambda, as you know, is a serverless service from AWS where you could write business logics without bothering much about the infrastructure requirements. Lambda being a serverless, it automatically handles the underlying infrastructure and all. It spins up. There will be a slight delay, which is very negligible, and you could execute your business logic. And similarly, Lambda can be connected to other services as well. There is a form of development called a serverless development, just by using these different serverless services from AWS. So that's a different topic. Anyway, if you want to leverage the Strands framework for those serverless systems, you could deploy that as a Lambda. One limitation with this is that when you deploy that as a Lambda, you cannot take advantage of that streaming support from the Strands framework. For streaming support, you need a container-based deployment. Otherwise, for other cases where you provide an instant response, other than streaming, you can use the Lambda. and the idea, the way by which you deploy is through a Python packaged Lambda, and it actually has a handler which does the different Python-based implementation of the Strands framework, and that option, that example is also available on the example section. If you look into the example section, you can see an example folder called examples slash CDK, where CDK is a kind of an infrastructure through a TypeScript format. You could create a Lambda service as well as the underlying the code for that using that CDK, and you could deploy that, and then that's one form of a deployment. So there will be a handler, so in such a deployment, once it's done, what happens is like your Strands framework agent will be running as a kind of a Lambda handler, and you could connect different triggers to that Lambda. It could be a trigger from HTTP, or it could be a trigger from an SQS, or from other event bridge or whatever. So for serverless or event-based approaches, this would be this is actually suitable. So mainly the code will be like a combination of CDK as well as the Python framework, Python-based code you will be writing, and already a lot of examples are provided for that Lambda-based deployments. You just have to change the underlying logic in between. Then another form of deployment is the container-based deployments in EKS and ECS, like a Fargate. Here what happens is, instead of Lambda handler, here we follow a different approach. Like we have a base wrapper package called which offers different endpoints that can be connected to these agentic systems, agentic methods, and then the actual agentic implementation will be written using the Strands framework. Different methods will be there, and you will be in that container, you will be different endpoints that can be handle the request from the outside caller to the specific Strands defined tools. So details about this kind of deployment is also mentioned on the documentation. You can go through that. Different deployment strategies are there. Another one approach is the concept of an agent core, where you can deploy this onto that agent core. Agent core is a new form of deployment. It's a runtime where you can develop the applications using the Strands framework, and then you can deploy that onto the agent core. Similarly, like the agent core, you can also deploy this on the EKS, that is the Kubernetes services. In the case of Kubernetes services, we have to use the EKS Auto, which is a kind of an autonomous mode for EKS, and you can deploy that. Then in EC2 also, you can deploy specifically for cases where you need to have a full control over the deployment strategies. So about the deployments, you can find a lot of different deployment strategies that are mentioned in the Strands documentation itself. You could check it out from there. Then along with the deployment, another important concept that you need to be aware of is the concept of monitoring and observability. By default, there is a logger available with the Strands framework, which offers a logging, and through which you can capture the different metrics, how it's performing, each of these performing, about these metrics and the traces. Traces means when you have multiple agents, you need to have a flow of how the flow is happening from one agent to the other. So the traces in each part of the trace, it will capture a snap of a specific agent based on the interactions, and there will be a correlation context that can be used across all these different snaps, so that the entire workflow can be traced out from that itself. So that option is also available. You can check on that. Similarly, the individual logging, in the execution of any specific part, if you want to log something, that option is also available there. So by this means, with the help of Strands framework, very easily you can develop a complex agentic AI applications, and then you can deploy on, and everything related to the security and other support for integration with other services. Everything is there within the framework itself, and AWS is pushing this on pushing this much farther, and they are adding more and more integrations on top of this. So that means you could simply create agentic AI applications very easily with the help of this Strands framework. So that is what I plan to cover in this today's session. So thank you everyone for tuning into Coding Talks podcast. A verbatim transcription of this will be available on my LinkedIn blog, as well as on my AWS Community Builder blog. I am an AWS Community Builder from past 5 years, now in the AI engineering track, and you could check it out, my blogs, different blogs, previous episodes as well. Thank you once again for tuning into Coding Talks. Have a great day.